All right, y'all. Good morning. Good morning. Hope your week is going well. Last week we started with factoring, like a factoring review, where we did GCF, difference of two squares, and just regular trinomial factoring. All right. So today we're going to look at factoring by grouping. The reason why I'm bringing this up is because, once again, next year when you start in Algebra 2, they're going to teach you factoring by grouping, but they also want you to be able to come in and already kind of have an idea of how to do it, okay? So we're going to look at factoring by grouping today. It's very simple. It's kind of the same idea as what you do in normal A equals 1 factoring, but when the A value in the quadratic or other functions that you'll learn in Algebra 2 is greater than 1, we tend to do factoring by grouping. There are a number of other methods, but factoring by grouping is the one they want me to focus on when you're doing it, okay? So I gave you kind of a step-by-step thing of how to work through some steps. So multiply A and C, and I highlighted what A and C would be, the first and last number. Find the factors that multiply to AC and combine to D. Add the factors into the problem and group them. I'll explain what that means. Factor out the GCF. So GCF stuff still comes into play here. And then write your answer in 2 sets of parentheses is still is like the last step, okay? So what I'm going to do now is do our first problem, okay? So the first thing we do, step 1, is you're going to multiply the first and last number. 5, I get negative 15, okay? So I'm looking for numbers that multiply to negative 15. And when I add them together, I get negative 2. So I'm looking for factors that when I multiply them, I get negative 15. So that's A times C, and they add together to give me negative 2. All right. Anybody got an answer for that? Multiply to negative 15, and when you add them together, you get negative 2 factors of negative 15. Okay. Yes, that's correct. So 3 times negative 5 is negative 15, and 3 plus negative 5 is negative 2. So those are the factors we want to use. So we're going to add the factors into the problem and group them in parentheses. And when we say that, what we mean is we're looking at the list of numbers here in our problem. So it's like I have 3p squared, so that's still a part of my problem. So I have 3p squared. All right. One of the factors was 3, so I'm going to add 3 and put a p with it. Okay. My other factor was negative 5, so I'm going to do minus 5 and put a p with the minus 5. And then my last number in my problem was negative 5, okay? Now, if you look, these two numbers here, those factors in the middle, they combine together to give you the middle term here, that negative 2. So we put the variables on them because we want them to combine and give us that middle term, that B term, okay? So we added them into our problem, all right? So step 3, we add them into our problem and we group them in parentheses. When I say group them, I mean you group the first 2 terms together and you group the last 2 terms together, okay? So we group the first 2 terms and we group the last 2 terms, right? So we're almost done. We have to factor out the GCF of each set of parentheses, all right? So we're looking at this first set right here. You have 3p squared plus 3p. What would be their GCF? The GCF for 3p squared and 3p, what would it be? Okay, so the numbers would be 3. What about your variables? Remember, you can also have a GCF of variables. Yes, Tristan, that's right. Yes. So 3p, going to divide out 3p from this one. And then on this one, we have negative 5p minus 5, right? So we have to get our GCF here. Once again, what do they have in common? Now, let me say this, because we didn't do a lot of this last week. Whenever you lead off with a negative number in your sets of parentheses for factoring by grouping, you're going to factor out a negative, okay? You're going to factor out a negative, all right? So like this is negative 5p minus 5. So the GCF here is going to be negative 5. And that's because this leading number in the sets of parentheses is negative. The same would have been true here, okay? All right, so when we factor out that GCF, I'm left with 3p on the outside here. I don't know why threes don't work. And so I'm left with p plus 1. And I factored out a negative 5 over here, and I'm left with p plus 1. All right, and I made a note here, factor out the GCF, what's left in parentheses should be the same. So if you look, what I have left in parentheses is exactly the same. So that means we did it correctly. If you have something different, that means something is wrong, all right? So we had the same thing in parentheses. So I write my final answer. I take my GCFs and put them in one set of parentheses. So I have 3p minus 5. And I only take one of the duplicate sets of parentheses here. I don't take both of them. So I'm just going to have one of the p plus 1s. And that is my answer. So I took the GCFs and put them in one set of parentheses, and I just took one of the duplicates and put it down in parentheses because it's really only there one time. Okay. Any questions on that one? Any questions there? P plus 1. When you divide out the GCFs here, 3 and 3 go, divide out p squared and p. Remember exponent rules? Subtract p to p squared, p to the first 2 minus 1 leaves me with 1p, and then 3 and p that divides out. Same thing here. When I divide out here, I end up with p plus 1. Does that answer that question, or was that what you were referring to? Okay, great. Any other questions? All right, we'll do another one. All right, let's look at this one. Number 2, we got 2n squared minus plus 3n minus 9. So remember, first thing is to multiply the first and last number together. So that's going to be negative 18. So I'm looking for numbers when I multiply them, I get negative 18. Okay. I get negative 18 when I multiply the numbers together. And they have to add together to give me positive 3. All right, so what are factors of negative 18 that when you combine them together, you get positive 3? Anybody got an answer? Factors of negative 18 that when you combine those factors together, you get a positive 3. Okay, yep. Yes, that is correct. So 6 times negative 3 is negative 18, and 6 plus negative 3 is going to give me positive 3. All right, so those are going to be the numbers we substitute into our problem. So the first term stays the same. So we have 2n squared. I'm going to put in the 6. Oh, and the order that you put the factors in, y'all, does not matter. I forgot to say that earlier, okay? The order you put the factors in don't matter. And so then I'm going to put 6n, because the first factor was 6 and the other factor was negative 3, so minus 3n. And then minus 9, okay? So that was the second step. I added the factors. That was the third step. I add the factors into the problem. And I'm going to group them in parentheses. So I'll group them in parentheses now, and that's a negative 3, okay? All right, so group them in parentheses. Step 4 is to find the GCF of each set of parentheses. So we have 2n squared plus 6n. So what would be your GCF for this set of parentheses for this first set? For 2n squared plus 6n. Yes, that is correct. So the GCF here would be 2n. So I'm going to divide this one by 2n. All right, because 2 is the biggest number that these are divisible by, and then n squared, and n is the smallest exponent. All right, and then you have negative 3n minus 9, negative 3n minus 9. So what would be your GCF here for the negative 3n minus 9? Yeah. Okay, so it's going to be negative 3. Okay, so when we divide through by the GCFs, that 2n is going to be on the outside, and on the inside of the parentheses, we're going to have n plus 3. And then for that second GCF of negative 3, that's going to be on the outside of the parentheses, and in parentheses, we're going to have n plus 3. So we got the same thing in the sets of parentheses, so we know that we did it correctly. So GCFs go in one set of parentheses, so 2n minus 3 go in one set. And then we only pick one of the duplicates. You don't use both of them, just one of them. So then we have n plus 3 on the other part. And that is our answer. Any questions on that one? Okay, we'll do one more, and that'll be it. Yeah, okay, I'm going to do number 6 down here, okay? So we got 2n squared plus 5n plus 2, okay? The same thing, multiply the first and last number together. So that's going to give me 4. So I'm looking for numbers when I'm multiplying the 4, they add together and give me 5. So what are factors of 4 that add to 5? Okay, sorry about that, y'all. Okay, so 4 and 1 is correct. So 4 times 1 is 4. 4 plus 1 is 5, okay? So in our problem, we're going to have 2n squared plus 4n plus 1n plus 2. All right, then we're going to group these together. All right. So we do our GCF, so the first set's of parentheses. So you got 2n squared plus 4n. What do you think that GCF is going to be for that one, the 2n squared plus 4n, that first set of parentheses? Okay, that is correct, 2n. So we divide by 2n on this one. And then on the second set of parentheses, we have 1n plus 2. Positive 1n plus 2. What do you think the GCF of that one's going to be? Yes, the GCF of that one is 1 because that's the only thing they have in common. So divide this one by a positive 1. So in the first set, I have 2n parentheses n plus 2. And then on the second one, I'm going to take out that positive 1. And in parentheses have n plus 2. Okay. So remember, GCFs go together in one set of parentheses. So that's going to be 2n plus 1 in one set of parentheses. And in our other set of parentheses, we only write one of the duplicates. So one of the duplicates is n plus 2. So that is the one that we write. And our final answer is 2n plus 1, n plus 2. And that is all there is to factoring by grouping. Do I need to do any other examples, or do we understand? You can just give me a yes or no in the chat so I know. Do I need to do any more examples of factoring by grouping? Okay, I got one. Okay. Okay. All right, so if that is it, I'm stopping the recording now.